Hi, I'm Doc Sanders. We are at the Society for Theriogenology meeting in Milwaukee, Wisconsin. The society is veterinarians that have a special interest in reproduction in a number of different animals, whether it be cows or horses or dogs and cats and that sort of thing. And I have with me today Dr. Martin Sheldon from Wales, who is also a veterinarian but has a unique perspective on the sciences and medicine and that sort of thing, and I want to share some of that with you today. Dr. Sheldon, would you give me, for the audience, some of your background of being a veterinarian and where you're at now?
Okay, so I was a veterinarian in Wales in farm animal practice for 15 years, starting in the 80s, and I developed an interest in reproduction and fertility in farm animals and became a consultant, and then I moved to the Royal Veterinary College, which is in London, to teach veterinarians and train future veterinarians. And then I developed a research interest in reproduction and fertility, and was very fortunate then to be able to develop that to the point where I've now moved back to Wales, and I work as a researcher at the School of Medicine in Swansea in Wales.
So what's really unique about this is he's in the human field, the College of Medicine in Wales, and originally his work was with cows and cow reproductive issues and uterine infections and that sort of thing. And would you share with us a little bit about why the cow as compared to humans with uterine disease?
Okay, so while I was in practice, we noticed that cows develop a lot of uterine disease, and in cattle this occurs after parturition. So in the weeks after parturition, they often develop an infection and they can develop disease. And we were interested in why that was happening, and my research now investigates the mechanisms of that. Why is it happening? What can we do about it? Can we find new insights to find new treatments? And the intriguing thing is that the other species that has a major and a similar problem is humans. And so that when we get down to the experimental level, working with tissues, the mechanisms in the animals are very similar to the mechanisms in humans. So the work we are doing can benefit both animals and humans.
And for our viewers, parturition referring to delivering a baby. And the interesting thing about this is that using the cow model to compare human reproductive disease with pregnancy, I thought when I first read of Dr. Sheldon's work that certainly we don't have near the amount of human reproductive disease, specifically uterine infections, as we do in cows. But I'm mistaken. Tell me about that.
Yeah, so I think partly because it's seen as a woman's issue, and secondly because it's seen as somewhat embarrassing. These matters are often not discussed openly, understandably, but in fact infections of the female genital tract, of the vagina and the uterus are common. They can be sexually transmitted infections, which are highly widespread and a real concern for our young people. These can often lead to more serious disease. And then there are other problems, for example, preterm labour, where women give birth to a baby prematurely. A proportion of these, about a quarter of these, are also associated with infections of the genital tract. And so these infections are far more widespread than might be the common popular view.
You know, Dr. Sheldon talks about them being widespread and the like. Share with us a little bit about some of those statistics for uterine infections and STDs and that sort of thing, particularly in Asia and some of the other third world countries. I was absolutely astounded with the numbers you presented today.
Okay, so in terms of sexually transmitted infections, the World Health Organization report that about 340 million new infections occur across the world each year, and Asia is a particular hotspot for that.
And so the mechanism for infections, uterine infections in women, is really not much different than what I am familiar with in treating cows.
That's right, yes. These infections are probably spread in similar ways. Infections or the microbes that cause these probably have the same mechanisms for reaching the tissues that they cause the damage in, and the diseases we see are very similar. So when it comes down to trying to understand how the bacteria or viruses work in the tissues, how they cause disease, and therefore how we might be able to treat them, there are great parallels between the two species.
So not only is this an issue, obviously, of things like childbirth, where we're concerned about sterility and sanitation and that sort of thing, this goes deeper than that in terms of the immune system and that kind of thing.
Right, and I think that's been the major advance over the last 5 to 10 years. We knew these infections were common, but we didn't really know a lot about how they were recognized in the body. And it turns out that probably as immunologists working for many, many years, we'd missed a trick. And it appears that there is underlying all the complexity of things like antibody responses and vaccine-type responses that people are familiar with. There is a more basic system of defense. And this defense system, which is often called the innate immune system, appears to be widespread across many species. In fact, it's common in particular things like jellyfish. So it's really widespread. It occurs in fish and flies and all the mammals, including humans. And it's remarkably similar between the different species. And so these innate immune mechanisms are very similar across these very wide species, as I say, from the fly or the jellyfish to the human. And now understanding these and how this system is able to very quickly recognize bacteria and viruses, and it really doesn't matter particularly the specificity of which bacteria it is. They just recognize all bacteria, and that allows the body to produce a very quick response, a very blunt response. So it's like an early warning system. It's watching for infection, whatever the infection might be. When it sees that, it then alerts the wider body systems, and more professional immune cells come in, and they then are like the policemen that say, yes, okay, we have a problem, or maybe we have less of a problem.
You know, I've understood the immune system for a long time and that kind of thing, but wait a minute, Dr. Sheldon, we're talking about something, if you're talking about jellyfish and that sort of thing, having that innate immune system, we're talking about something that's very primitive, that's been here ever since mankind has been here.
Yeah, and I think that's the striking thing about it, and people have done quite a lot of nice work, particularly in the US on this, showing that there has been co-evolution of these systems. And if you think about it, the fundamental features of life, whether you're a jellyfish or a human, you've got to maintain your metabolism, you've got to get food, you've got to reproduce, so you've got to have fertility, and of course you've got to be able to defend yourself against oncomers, bacteria and viruses. And so these things in mammals have probably co-evolved for 300 million years, and so they're well integrated, and at this fundamental basic level, that's probably why they're so important in the reproductive tract.
So here we are with science today being very sophisticated, and yet we're talking about an immune system that developed with evolution clear back when it was jellyfishes and not humans and that sort of thing. And we are trying to understand those issues that we're protected against with our immune system. That's really astounding when you consider those things that are occurring. Now, do you see that being something that's going to be diagnostic in the future, of being able to pick up on issues with the immune system before the infection becomes serious and where are we headed with this?
Okay, so I think the important thing to understand, and I think your current president has made this point, that by understanding basic science, by understanding these fundamental mechanisms, I'm not going to promise you a treatment or a diagnostic tomorrow or in 10 years. It's probably our children who are going to benefit from this. It does take time. But I think the critical thing you find if you look back in science is that if you understand the fundamental mechanisms that relate to particular diseases, that allows you down the track to develop, yes, maybe a new diagnostic or a new way of evaluating how severe the disease is, or to develop a new treatment. Because you're not just trying things out, oh, let's try this and see if it works. You're thinking about how the bacteria or the virus get into the tracts, how they cause a disease, how the immune system responds. And what you're looking for is the good things that the body has to mimic and the bad things about this that you can fight against.
You know, in the past, and many people have heard me say this, that cows, by virtue of milk, are the foster mothers of the human race. But you know, cows contribute more to our society than we originally realized. And here we are with Dr. Sheldon today talking about understanding the immune system of cows and applying it to humans and to make health better and safer for people. Dr. Sheldon, I really appreciate you coming today to visit us and share with the veterinarians attending this meeting. And I know there's people that's going to want more information and the like. Where can they go to find out and learn about your research and what's being done in the world?
Okay, yes, we have a website, and it has some simple messages for the general public as well as a lot of the other information. And if you go to www.crib, which is CRIB.Swansea, Swan and then SEA, at .ac.uk, you can find all information there. And it's been a pleasure coming to visit Milwaukee and a pleasure to come to this conference.
Dr. Sheldon, on behalf of all the veterinarians here, we are receiving lots of information, and we're really grateful for your input in this meeting. It's been invaluable.
Thank you.